Hi everyone, today I'm talking about IDLE Studio, a structured editor for authoring interactive and data-driven documents. I'm Matthew Conlon, and this work was done in collaboration with Jeff Hare at the University of Washington, along with Megan Bowen Allentan of the IDLE Open Source Collective. Interactive articles are popular in domains like data journalism and scientific communication because they can foster more engagement from readers and result in improved learning outcomes. But these benefits come at a cost. The articles can be difficult and time-consuming to produce, and are often only a feasible option for those versed in general-purpose programming tools like JavaScript and the command line. In this work, we extend and build upon IDLE, an existing toolkit for developing interactive articles. While IDLE requires users to write markup, with IDLE Studio, we attempt to lower the threshold for authors to create interactive articles through a WYSIWYG-style editor, allowing non-technical authors access to the medium and enabling technical authors to develop articles more rapidly and with less cognitive overhead. Now, let's start by jumping right into a live demo. I'll start with an overview of the basic interface. In the main panel, we have a document rendering. I can interact directly with the text of the article to edit it, and use Markdown syntax for basic styling. The left sidebar contains 3 tabs. The Document tab controls top-level information like the theme and layout being used, metadata for social media and search engines, and buttons to preview and then ultimately publish the article to the web. The Components tab allows me to add components to the document. For example, I can search for a table and then drag it onto the page. Components are grouped according to their functionality, and authors can add their own custom JavaScript components as well. The Variables tab allows me to create reactive variables and import tabular datasets. I can create a new variable by clicking this button and then setting its name and assigning an initial and current value. And I can import tabular datasets by taking a JSON or CSV file from my file system, dropping it onto this panel. Components are all annotated with a small icon, which can be clicked to reveal an editing instrument. For example, clicking the header components icon allows me to edit the title, subtitle, date, authors, and so on. The table component expects a dataset as an input property. I can drag the imported dataset onto this property to connect it to the table. Notice that it immediately starts showing rows from the dataset. Properties have different types, including literals like numbers, booleans, and strings, variables which create a two-way binding between the property and the variable, and expressions which are reevaluated as variables change. These simple constructs can be combined to rapidly create interactive articles. For example, let's say I want to add a dynamic sentence that stated, if my dog is X years old, that's equivalent to 7 times X in human years. And I want readers to be able to manipulate this value X and see the equation update in real time. I'll start by creating a new variable to represent the dog's age, give it a name, and I'll start writing my sentence. I'll say, if my dog is, and now I want to add a component that will allow readers to manipulate this value. So I'm going to drag and drop a scrubbable value and put it at the end of my sentence. And I'm going to set its value to dog age. So now we see, as I scrub this, the current value of the dog age variable is updating in real time on the left. I'll also edit some of these other properties like the minimum and maximum value to make it appropriate for the sentence at hand. And I'll keep editing my sentence. I'll say years old. That's equivalent to, okay, now I want to have 7 times X, and I don't want readers to be able to edit this. I just want to display this expression. So I'm going to add a display value. I'm going to edit its property and set it to an expression that is 7 times dog age. Okay, and now we can see that as I scrub this number, that's going to update in response 7 times. And I'll finish the sentence finally, in human years. All right, I'll delete my example. And let's see, we have a fully working sentence. Under the hood, the application starts by parsing an arbitrary IDLE program and generating an abstract syntax tree representing the structure, text, components, and reactive variables constituting the interactive article. We then modify this AST by inserting instrumental components, including text editors, insertion points, and component editors, which are used by authors to make changes to the article. The modified version of the AST is rendered into the IDLE Studio GUI. As authors make edits, a new version of the IDLE program is serialized, starting the loop again. To implement this architecture, we extended IDLE to support reflection, allowing components to read and write to the underlying program as it runs. To assess the effectiveness of the editor, we conducted a study with 18 users, including journalists, researchers, and data scientists. Participants were assigned a technical score based on their familiarity with various programming and data science tools. After a 5-minute tutorial, participants were given 30 minutes to complete a series of 6 tasks: a basic, intermediate, and advanced task, along an interaction track and a data-driven track. Each task required implementing a small self-contained design that frequently appears in interactive articles. The results can be seen here, with each row corresponding to a participant, with the most technically savvy participants at the top, and each colored column corresponding to a task. With one exception, all participants completed both of the basic and intermediate tasks. A participant's ability to complete the advanced tasks was highly correlated with their technical background. Through semi-structured interviews, we found that the interface enabled users to rapidly create designs with less stress compared to existing tools, but there was a learning curve for some authors. Participant 9 said, "Adding the interactivity and putting it into text. If you wanted to do it in another way, you could, but it's more work and more stressful." Participant 15, "What I really like is to drag and drop components and then wire them up with point and click." And participant 17, "It's fully something I would use. I don't have the time or energy to code from scratch." While all of the users were able to figure out the basic primitives of the system, when asked to compose these building blocks together, some users needed more time to learn. Participant 3, a more expert user, said, "I came in with a slightly wrong preconception, but that was all of 30 seconds or so." While less expert user participant 17 noted, "Everything logically made sense, but it took some time to think through things." And participant 15 said, "I would have to do it a few times to get that to work." Still, the interface empowered users and provided better support to users compared to existing tools. Participant 18 noted, "Sometimes I use PowerPoint, but it is limiting. I can write a little HTML too, but that is also limiting." And participant 17 said, "I don't have a good workflow. I've tried other tools and just gave up. I have used observable notebooks. It's a bit confusing. I get overwhelmed." To recap, we presented 3 main contributions. We extended IDLE with support for reflective documents, allowing authors to interactively edit articles at runtime. We use these extensions to power IDLE Studio, a WYSIWYG-style structured editor. IDLE Studio is open source software that can be downloaded and used today. Finally, we evaluated the usability of the editor. Our system helped make the authoring process less stressful and limited the need for authors to use general-purpose programming tools. With that, I'd like to say thank you for listening and open it up to questions.